Hi everyone, we're going to go over today how to add and subtract fractions with unlike terms. I know this is probably a review for you, but it's always good to double back and make sure that we know how to do this before we get into more complicated stuff. So let's take a look here. So like I said, we're going to add and subtract fractions with the unlike denominators. So let's take a look at a problem here. Let me move myself out of the way there. The Pacific Ocean covers 1/3 of the Earth's surface. The Atlantic Ocean covers 1/5 of the Earth's surface. To find the fraction of the Earth's surface that is covered by both oceans, you can add 1/3 and 1/5 together, which are unlike fractions. What makes them unlike fractions is they're representing different parts. That denominator there, 3 and 5, are not the same, which poses a little bit of a problem. So let's think back to something simpler. So what about this problem here? Here we have 1/8 plus 5/8 plus 3/8 plus 2/8 plus 1/8. So we can just think of fractions as a unit, like an apple or an orange. 1 apple plus 5 apples plus 3 apples plus 2 apples plus 1 apple. How many apples do you have? In this case, we don't have apples. We have these things called eighths. So we have 1 of those things, 5 of those things, 3 of those things, 2 of those things, and 1 of those things. So really all we're doing is adding that top number, or how many of those units that we have. So 1 plus 5 is 6, plus 3 is 9, plus 2 is 11, plus 1 more is 13. No, it's not, it's 12. 1 plus 5 is 6, plus 3, plus 9, plus 2 is 11, plus 1 more is 12. So that is 12 of these things that we call, 12 of these things, let me grab a pen here, 12 of these things that we call eighths. And we know 8/8 make up 1 whole. So we have 1 whole and 4 of these eighths left over. And if we can simplify that, we can even make that into 1 and 1/2. That's how we do that. Now that's easy because we have a common denominator. These are called like fractions because they have that same bottom number. We're representing the same fractional piece there. So that's the easy stuff. So now what's a little bit more difficult is when we have unlike denominators. So let's think back again here of what fractions mean. That bottom number means how many parts we need, our denominator here, the bottom number, how many parts we need to make up a whole. So if I have 2 of these halves, I have 1 whole. If I have 4 of these fourths, I have 1 whole. If I have 8 of these eighths, it's 1 whole. Or 3 of these thirds, it's 1 whole. It's important to know how to make that whole fraction. A bunch of ways to represent one using fractions. All right, so here we go. Here we have 1/2 plus 3/4. We're adding these two together. Now I can't just go and add these. I need to find the least common multiple of 2 and 4. 2 and 4 are my denominators. Now, LCM is the way we represent least common multiple. And sometimes we call it the least common denominator when we're talking about fractions. But really, it's the least common multiple. So really what I do is I look at the larger denominator, the larger number in the bottom here, and that's 4. So I start thinking the multiples of 4. Well, the first multiple of 4 is 4 times 1. It's 4. Can I get 2 to be 4? Yeah, if I multiply 2, if I look at the other denominator 2, can I multiply 2 to get to 4? Well, yeah. So that makes it kind of simpler. So let me see if I can scroll down here a little bit and bury that problem a little bit. So I have to rename each fraction. So if I look at the model here, I can see that 1/2 is equivalent to 1/4. But what if I didn't have that model? And eventually we're going to get so that we're not using models. So I can multiply 1/2 by 1 and always end up with 1/2. Well, that's essentially what I'm going to do here. So I need to make 4 on the bottom here because I need a common denominator of 4. So what can I multiply 2 by to get to 4? Well, I can multiply 2 times 2. That's a times. That dot represents multiplication. If I do that to the bottom, I also have to do it to the top. But really what I'm doing is multiplying by 2 over 2, which is 1 whole. And then we know anything times 1 is equal to itself. So 1/2 times 1 is 1/2. In this case, I'm using 2 over 2. So 1 times 2 is 2. And 2/4, and 2 times 2 on the bottom is 4. So 2/4 is equal to 1/2. And we know, because really all I multiplied 1/2 by was 2 over 2, which is 1 whole, so it's still got to be equal to itself. It just looks different here. So now that I have 2/4 and 3/4, I can add them together and get 5/4. Now that's an improper fraction, and we can turn that into a mixed number. So I know 4/4 makes 1 whole, and then I would have one of those fourths left over. So that's how we do that one. So let's go on. All right, to add fractions, first rewrite them as equivalent fractions with a common denominator. That's what we did. We changed 1/2 into fourths. And then fractions that represent the same value are equivalent. So 1/2 and 2/4 are equivalent fractions. They both mean 1/2. But we can just add them together when we have common denominators. So take a look at these. Attempt to do these on your own. All right, so what does this look like in a word problem? Mark made a pizza with pepperoni covering 1/4 of the pizza and onions covering another 1/3. What fraction of the pizza is covered by pepperoni or onions? So, and onions it says, but or onions. So what fraction is covered with some topping here? So our problem here is 1/4 plus 1/3. So we're going to add these fractions together. So our problem here, we look at the bottom, we don't have common denominators. So what is a common denominator or a common multiple of 4 and 3? So I look at 4. First multiple of 4 is 4. Second multiple of 4 is 8. So 3 doesn't go into 4, so I can't multiply 3 to get to 4. The next multiple of 4 is 8. Can I multiply 3 to get to 8? No, I can't. So go up another multiple of 4. So 4, the next multiple would be 12. Well, 3 times 4 is 12. So this will work as our common denominator. So I need to change both of these denominators now. So we said 12 is going to be our common denominator. So really what I did here, and I'm going to show you here, hopefully I can write small enough. Let me change this size of my pen a little bit. Yep. So really I'm multiplying 4 times what? I'm multiplying it times 3, and the top times 3. So 3/12 is going to be the same as 1/4. And then down the bottom, I got to multiply 3 to get to 12, and that was times 4. And whatever I do to the bottom, I do to the top. And that's how I end up with 4/12. Now I can add them. I cannot add them when they're in this form. 3/12 is the same as 1/4, and 4/12 is the same as 1/3. But I have common denominators. And once I have common denominators, all I need to do is add those numerators together. So there it is again, written for you. Move myself out of the way a little bit. All right. Another one here. Tori made a pizza with peppers covering 1/3 of the pizza and ham covering another 1/2. What fraction of the pizza is covered by ham and peppers? So we're adding here 1/3 plus 1/2. So if we look at this model, sometimes it's helpful to see a model, but we're adding 1/3 and 1/2. So 1/3, so I'm going to write it out like this, 1/3 plus 1/2. We don't have common denominators, but if we look at the model down there, it's kind of given it to you already. But if I look at 3 and 2, what can I multiply together there? Common denominator, common multiple is 6. So I'm going to start down here at the bottom. 2 times 3 is 6. So that means I have to multiply the top also by 3. Remember, 3 over 3 is 1 whole, so we're really not changing the value here. We're just changing the way it looks. So 3/6 is equal to 1/2. So up top here, so 3 times 2 gets me to 6. So whatever I do to the bottom, I do to the top. And that's 2/6. Now I can add, once I have this common denominator. 2 plus 3 is 5, and that comes out to 5/6. We need that common denominator here to do this. You can use any common denominator. You don't always have to find the least common denominator, especially when you have those weird denominators like 17 and 16. I don't know my 17 and 16 multiples, and I doubt many people do. So let's do this one. We could use the multiples of 10, but if you didn't know that 8 and 10 have a least common multiple of 40, what can you do? Instead of spending all that time trying to find one, what you can do is find a common denominator, maybe not the least common denominator, but you can multiply those two together. Because we know if we multiply 8 times 10, that comes out to 80. Well, we know 8 goes into it and 10 goes into, because we just multiplied those two factors together to get 80. So we're going to do, and this is subtraction, so the first number has to go up top if we're stacking them. And then 3/8 will go on the bottom. And we multiplied 10 times 8 to get 80. So we're going to change these so that I have 80 on the bottom. So 8 times 10. So then 3 times 10, that gives me 30. And then 10 times 8 gives me 80, and 7 times 8 gives me 56. And remember, we're subtracting here, so here's my subtraction problem, 30 from 56. 56 minus 30 is 26. I'm going to write it up here so I have a little bit of room. It's 26/80ths. Now I'm not done, because I have a number on top, number on the bottom that have a common factor. They're both even numbers, so I know I can divide by 2. So if I divide the top by 2, I have to divide the bottom by 2, because any number divided by 1 is equal to itself. But 26 divided by 2 is 13, 80 divided by 2 is 40, and I don't think anything else divides evenly into 13 and 40 other than 1. So circle that and be done with it. You're done. Let's keep moving on here. So now what happens when we have these mixed numbers and whole numbers? Well, I can't take 1/3 away from nothing up here. I have a whole number, 4, minus 1 1/3. A lot of people try to do that, but let's look at a simpler problem here. Let's say I had 30 minus 18. Now when we do that, there's nothing there, in that 0 is representing nothing. I can't take 8 from 0. Remember, we have to do this borrowing or regrouping that you did back in elementary school. Well, it's kind of the same thing here, right? And then that would be 10 ones now, and now I can subtract and I get 12, right? We wouldn't think of doing it the other way, just taking 8 from 0. That doesn't give us 8. We know that. So it's the same thing here when we're dealing with fractions. So there's nothing here. There's nothing in there for me to take. So if we look at 1 whole, if we just cash in one of these 4 ones that are really over here, if we cash them in, what are we going to cash them in for? We're going to cash them in for thirds. So I know 3/3 make up 1 whole. So really, and why am I using thirds? I could use fifths, I could use halves, I could use all of those. But I'm going to take, let me erase that box. So I am going to take from this 4, I'm going to make that now 3. I'm borrowing 1. 3 plus 1 is still 4. But instead of 1 whole, I'm going to take 3/3. 3/3 is 1 whole. So 3 plus 3/3 is still 4. But why did I use thirds? Because my denominator down here that I'm working with is thirds. So I don't want to change it into 5/5 and then I have to find a common denominator again. You get to choose. Any number over top of itself is equal to 1 whole. 5/5, 4/4, 2/2, 100/100. So now 1/3 from 3/3 is 2/3, and then 1 from 3 is 2. That's all we have to do with that one. Let's look at one more. That was a whole number there. But what happens now when we have this? So 3/4 from 1/4. Well, I can't take 3 from 1, just like, and I'm going to show you another problem here. So let's say I had 32 minus 15. I can't take 5 from 2, so again, I have to borrow. And this now becomes 12. And now I can subtract, right? And then I get 17 is my answer there. So that's an easy one, and we know how to do those. It's really the same thing when we're dealing with fractions here in these mixed numbers. So I can't take 3 from 1, so what am I going to do? I'm going to borrow 1 whole from there. So I'm going to make 3 2, and instead of 1 whole, I'm borrowing 1 whole as a fraction. So what fraction am I going to use? Well, I could use 3/3, I could use 2/2, but why? I have a denominator of 4, so really, I'm borrowing 4/4. So 2 plus that 1 here, represented as 4/4 in this case. I'm going to add to the 1/4 that I have. So now, 2 and 1/4 is the same thing as, or 3 and 1/4 is the same thing as 2 and 1/4 plus 4/4 is 5/4. So now I've rewritten it so that I can subtract 3/4 from 5/4 is 2/4. And 1 from 2 is 1. That's your answer, and we can simplify 2/4. So this is 1 and 1/2. That is your answer. Okay, it's borrowing, just like, or regrouping like we did when we were adding back in elementary school, adding and subtracting back in elementary school.